All right, it is 11:30. Let's get started. Excuse me. So there are a few things before we get started. I'm going to go over some introducing myself and going over some nuts and bolts of WebEx. My name is Bree Rivera. I am formerly the ADE's K-12 Science Specialist, and currently I work at Mesa Public Schools as their Secondary Science Specialist, and I am helping to roll out professional development as the state is learning about the new standards. If you hadn't had a chance to share, please feel free to continue sharing. I'm going to move on. And you are now here for Tool 2, and that is part of the 5 tools of using our Arizona Science Standards to plan classroom instruction and assessments. And this one is going to focus on a little bit of backwards planning and getting you in the mind frame for assessment. Let me go back. So this was developed by BSCS, Biological Supply Curriculum Study, in partnership with the American Museum of Natural History and West Ed. One thing I like to say about this program is that it may not be for all people, but it is a very organized way of looking at the standards and creating units based on that organization. So we just talked about Tool 1, and I'll go over that again in a little bit, but we really looked at the organization of the standards. This is also a good resource to share because it is completely free. So it is hosted on the American Museum of Natural History's website. All you have to do is Google American Museum of Natural History, 5 tools, and you will get all of the resources for free, from their facilitators' guides to the handouts to templates. Everything is free. However, it is geared towards NGSS and not our Arizona Science Standards, so that makes it a little bit more difficult to work with. So to help you out, I have created a Google Drive folder, and you can access that Google Drive folder from the email reminder I sent you, and I have those templates and some of those items more towards how they would work with our Arizona Science Standards. So like I said, we just completed Tool 1 at 9 a.m. this morning, and in your second email reminder that I sent out just before this webinar started, I did link a video of Tool 1, one that we recorded a few months ago, if you wanted to go back and look at that. But today we are going to focus on Tool 2, and that is where we are going to use the evidence of learning specifications to sort of backwards plan our unit. So in Tool 1, we created a blueprint. We have organized our standards. We know the order we want to teach them in. We understand what science and engineering practices we need to teach that standard, as well as the cross-cutting concepts, and we know the lens or the focus of the using science. Tool 2, we're going to create evidence of learning specifications. Tool 3 is where we're going to create a storyline and pick our phenomena to help teach our standards. Tool 4, we use that storyline and everything we've done so far to select resources to teach our unit. And in Tool 5, we create our unit assessment. So in Tool 2, we are going to start to plan the assessment and the evidence of learning for our unit. So it's kind of taking a backwards design approach where we think about the assessment before the instruction. And we look at the standards, our new Arizona Science Standards, and we develop what we call evidence of learning specifications, and they describe what qualifies as evidence for student proficiency of the standard. So teachers, then you're going to go on to develop in Tools 3 and 4 your actual unit. And as you're doing that, you need to go back and revisit these evidence of learning statements to make sure that you're staying in line with what you want your students to learn. Okay, so when you're thinking about assessments now, what are the characteristics of high-quality classroom assessment? Take a moment to think and then share your ideas in the chat box. Okay, so assessments need to be real world and tied to instruction. They should measure what was taught and provide evidence of learning at different levels. Hopefully they can help students explain what they've learned in concepts in their own words. They can transfer that knowledge to other situations. That's really important. The assessment is focused on learning objectives, which are hopefully tied to the standards. Good. I like to see assessments as a way for students to show what they have learned, to feel confident in themselves, give themselves that pat on the back. They can be formative or summative, yep. And they should be ongoing, not just a one-time thing. I agree with everything you guys said. Before we start developing evidence of learning statements, here are some facets of high-quality assessments. So the diagram you see is adapted from an assessment framework developed from the NSF-funded research project. And the people who went into this one graphic was UCLA, Stanford, Berkeley, Lawrence Hall of Science, and West Ed. All worked on this framework and with this idea of quality assessment. So the three facets of high-quality assessments are represented by the three sides of this triangle. And we have our quality learning goals, quality tools, and quality use of assessments. So we can kind of think of the quality learning goals, and that we can think of them as the three dimensions of our Arizona Science Standards. We can think of the tools, and they include the tasks and the prompts and the rubrics and the scoring guides that we use with students. And then our quality use is what do we do with that information? How do we take that data that we got from the assessment and how do we use it to guide our instruction? So how does that work with the 5 tools? In Tool 1, we developed that 3-dimensional blueprint, meaning it had the core ideas, the cross-cutting concepts, and the science and engineering practices for a unit that contains roughly 3 to 5 instructional sequences that align with the learning goals in our Arizona Science Standards. Right now, we're going to develop criteria or evidence for learning specifications in Tool 2 that will inform the development of those quality assessments. And then later, we're going to use all of the tools, 1 through 4. And then we will look, when you look at Tool 5, you use those evidence of learning specifications to develop a performance task or an end-of-unit assessment or a rubric to serve as that assessment tool for you. But before we start with Tool 2, let's look at the types of classroom assessments to make sure we're all using the same terminology. So in the chat box, what does formative assessment mean to you? And what does summative assessment mean to you? And you can just choose one and share out what does formative assessment or summative assessment mean to you. So far, formative is what the student is learning. It is a checkup, making sure students are getting what they should get. It's ongoing. It tells us where to go next with our instruction. Summative is like the end of a unit assessment. Summative is a measure of student knowledge. Summatives are more in depth. And you guys hit formative assessment right on exactly what you guys said. It becomes more formative in nature. It helps us gather some data to help us inform teaching and or influence the learning of the students based on what we learned. The summative assessment, again, is exactly what you guys said. It measures the student progress at the end of instruction to demonstrate the achievement of the learning goal. So in order to be able to describe, because this is kind of a hard skill that we are going to be working through and I feel like this is maybe a little bit more difficult of an environment to get the meaning across, is that we are specifically wanting to spell out what it looks like if a student is proficient in the performance of the Arizona Science Standard that you are working on. And to do that, we are going to write evidence statements. They must provide a clear, measurable component that, if met, fully satisfies the standard. Now, our standards are three-dimensional, meaning they have core ideas, cross-cutting concepts, and science engineering practices. So that means these statements should provide detail on how students will use the practices, cross-cutting concepts, and the core ideas together to demonstrate that they are proficient on the standards by the end of instruction. So the first thing we have to do is figure out what are the standards, and we did that in Tool 1. We've had those deep conversations. We unpacked the standards. We made a storyline with the learning progression and matched the standard up to it. We are clear on what the standards are. Now we're going to look at what is the evidence of learning specifications, writing it out, that will let us know the students have learned the standard. And then we can take these later on in the process and develop a classroom assessment. Okay, so I'm going to walk you through an example. And this one's going to be a fun example before we actually try a standard. So this is going to be an everyday example to highlight the kinds of thinking that you'll do and structure and how you're going to structure those evidence of learning specifications. So I'm going to ask you to plan an interactive dinner party. I have a little bit of a clarification statement on that performance task. The dinner party is for 8 to 10 friends who are acquainted with one another. The dinner party is not associated with a special occasion or holiday. Giving you a second to think about that. So let's look at this statement three-dimensionally. The core idea is that people, food, and beverage are an important component of a dinner party. The practice, or the science and engineering practice, would be planned for an interaction. And the cross-cutting concept is that community and belonging require the development of relationships. All right, in the chat box, let me know evidence that we have performed this standard. What is evidence that we have planned for an interactive dinner party? And you can do short ideas and continue to add as you get them. Good, so we're seeing a list of people, food, and beverages. We have a menu. You plan for a game or some way to make sure that your guests will interact. And then we have some other ideas on here, like your friend showed up, your guests are happy at the end of the evening, no one wants to leave, people are talking, they're engaged, they're interacting. And then I'm going to have you look at it again. When I went through this training, we had the exact same responses that you guys are giving right now. Let's go back and look at what we are asked to do. It says to plan an interactive dinner party. Does it say that we are giving the party? So going through, I'll pick out the evidence that you gave me that shows that we had planned the party, and that was you guys definitely said a lot of them. You made a menu, a guest list, you planned out games or interactive things for people to do if you actually host the party. You planned to set up physical environment. Maybe you made a plan of the table layout and how everyone's going to sit, and maybe even had a seating plan. But anything that you did to plan the party is going to be your evidence for this particular, and we're calling it a standard. I've heard email out for prepare an email that will ask for allergy issues, but anything that you do to prepare or plan for that dinner party. So here's what we did. Here is our standard, plan an interactive dinner party. Our plan for interaction includes a guest list, which you guys said, of 8 to 10 friends who are acquainted with each other, lists of wine or other beverages that go with the food, beverages for people who are non-wine drinkers, menu and shopping list for food based on dietary needs of guests, or a sketch of a seating area. All of those are evidence that you have planned for an interactive dinner party. So while we're writing our evidence of learning specifications, hopefully you keep this real-world example in mind. But the first thing we need to consider is the standard. And we already have our standards in an instructional sequence from Tool 1. And then did we talk about in our groups anything that was clarifying, or maybe some assessment boundary where we are keeping our boundaries as we are teaching? those would also fit nicely in the Tool 1 template, and there's a spot for them, even though in some places the learning progression of the Arizona Science Standards do give you a boundary, and some places they don't, and maybe you want to define those on your own with your teams. We definitely want to look at the science and engineering practices, the core ideas, and the cross-cutting concepts that we identified in Tool 1, and our science and engineering practices from the standards, because our standard does give us a science and engineering practice that we need to meet with that standard. So this is what the Tool 2 template looks like. It is very simple. And again, in your Google folder, you have a editable version of this template. And what you would do is you would write your standard here. You would list your science and engineering practices and your using science that you identified in Tool 1 here, and maybe give some more clarification, like I gave you guys the food web cards to develop a model example. Maybe you want to make a note of that there too. Then your background science engineering practices and core ideas, the ones that you want to assess. And then anything from your template that is not assessed, you're not going to have a formative or summative assessment on. You kind of just want to know that it's still important. But what you have identified. So we kind of talked about this in the last webinar, but the foreground is something that is most prominent or the most important feature, and it's right in front of you, and the background is what's behind something. It's still important, but it's not the main focus. So here is our instructional sequence, and we have sequence 1, 2, and 3 shown on the screen of the same topic we were talking about before: ecosystems, interactions, energy, and dynamics. I'm just going to give you a couple seconds to review those standards. Allison, you probably didn't miss Tool 2. That was the last tool I edited, and I may not have put it in the folder yet, but it will be in there by the end of today. Okay, so in this instructional sequence, we are looking at 2 standards that have students develop and use models. And this one is just develop a model, and this is develop and use. And there's a really good opportunity to bundle these 2 standards together. And as we do one, we teach the other. And then we have a standard that deals with human impact on ecosystems and how organisms compete with each other for resources. And we're going to look at instructional sequence 1. And we're going to place that standard in our standard box. We're going to add, and so we considered the standard, and we didn't really have an assessment boundary for that one. But if we were to, I always go back and reread the learning progressions from the standards document again, just to make sure that I have all of that down. But we're really going to focus on develop and use models to demonstrate the interdependence of organisms and their environment, including biotic and abiotic factors. So we really need to think about what that big idea is, and to do so, we really need to read the learning progression, all of our sticky notes of what we said was important, and the standard, and really make sure that we're combining all of that information and thinking about it all at once. Not just focusing on the standard, not just focusing on the learning progression, but everything. Then we're going to add in our science engineering practices, our core ideas, and our cross-cutting concepts to make those connections. So when we're looking at our evidence of learning specifications, we're going to write statements, kind of like we did with the dinner party, that show students have mastered that particular standard. And our standard said that students need to develop and use models that. And I've color-coded them with what the framework has. The framework always has the science engineering practices blue, the cross-cutting concepts green, and the core ideas or the content in orange. So you're going to see the same color coding here. So we see that visually this is a three-dimensional statement. It may not be the best three-dimensional statement, but it is a three-dimensional statement. And we start with the skill that we want students to learn, and that was to develop and use models. And we want these models to demonstrate possibly the patterns of interactions between the living and non-living parts of an ecosystem. And we want to include those different types of interactions among organisms. And this is a good start. And this is a good start to writing an evidence of learning specifications. It's not very specific yet, but it kind of gets an idea of where we should be going three-dimensionally. So we have our science engineering practice, we have our cross-cutting concept with patterns, and we have our content. I always like to go back and double-check that I've seen everything. So I know that my science engineering practice is to develop and use a model. So I'm going to put that in my foreground. I know that some background information that I want the students to do is to, once they've used their model, I want them to construct an explanation. And this is something I do want to assess. I know it's not a specific part of the standard, so I'm going to put it in the background, but I want to assess it. And while they're working on their models, I want them to engage in argument from evidence. I want them to focus on the patterns that their model is showing them. But I want them to know that they are using a model, and this model is part of a bigger ecosystem. My using science is U1. They're gathering information, they're going to do some investigating, they're going to be doing some models, and then they're going to explain what they've learned, and that's what U1 tells me. And for this particular set of two standards, I'm not going to focus on that sometimes damaging or destroying natural habitats may cause the extinction of many other species. That was something that was in the learning progression, and I may touch on it in another standard even in the same grade level, but for this particular set of evidence of learning specifications, I want to write them to standard number 13. I'm not going to focus on them right now. From my sticky notes, some things that I had that were important that I should focus on are some of these terms, and I really want to make sure that my students understand competition, predation, energy, that organisms definitely depend on one another, and that could be any of those symbiotic relationships with mutualism or commensalism or parasitism. But I really want to make sure that at some point in my unit I am thinking about checking for understanding for those particular terms. And I also need to make sure that my students understand, and they're in 6th grade, so they should have seen an ecosystem once or twice, but make sure that they understand what an ecosystem is. And I'm also going to be asking them to graph some data that I'm going to want to give them as they're analyzing their ecosystems and their food webs. So in the template, I put everything that I want to think about as evidence that they have learned Standard 6, number 13. I could add a lot more to this, and this is why it's a little bit difficult to do it on this online format, but I could definitely add a lot more to this. But I'm going to now think about what I've already written and make sure that I turn those phrases that I just gave you into clear statements that show evidence that a student has learned the topic. I also want to make sure that my statement is three-dimensional. I've used all of my ideas from Tool 1. And like I showed you that first try, I said it wasn't a perfect statement, but I just wrote down my ideas, something on paper. And this was my first, this is a little bit more of a revised model. So I'm going to have my students develop a model that shows consistent patterns of interactions between living and non-living parts of an ecosystem. So I said I wanted to make sure that my students knew what an ecosystem was. I'm really going to highlight in there. I want them to know those interactions, but I also want them to make sure that I'm very specific about those interactions. So I want them to develop a model that shows consistent patterns of those types of interactions, including competitive, predatory, and mutually beneficial. After this, I would go into another series of statements, and I would say develop a model that shows, and I would go back to my chart, and I would write statements that shows that students are constructing explanations and what that can look like. So I could have my students construct an explanation that predicts consistent patterns of interactions between living and non-living parts of an ecosystem, and consistent patterns of types of interactions, including competitive, predatory, and mutually beneficial. Making sure that I hit all of the science and engineering practices that I said were very important. And then this one is cleaned up. Any questions on the evidence of learning statements so far? Yes, I agree. You need practice with this. And it was one of the reasons why I left it out of the series that we did a few months ago, was because I kind of felt it would be difficult to do online, but I got a lot of requests, please go back and create a tool 2. So I worked on it. And then back here, I said that we could easily bundle these two standards together. for the predicts, it wasn't a part of the standard. When I went back, and that's a really good question, let me kind of exit out of here and then see if I go here. And I know I showed you this in Tool 1, so for Tool 2 people who are just here for this webinar, this is a new document that has been added to the Arizona Department of Education's website, and it's called the Vertical Progression in the Science and Engineering Practices. And I use these documents to help create the blueprints. So looking at my 6-8 examples, because it was a 6th grade standard, when I look at these elements, I saw this a lot in them. Use and develop models to predict. And that's where I got the predict from. You can explain a phenomena or a science concept by making a model. So you can, in my mind, the model, for this particular unit in Tool 1, we discussed a food web that is cards, and the students can create their own model with the cards, and it's their own unique ecosystem. Like, give them 30 different animals and they can select a few and create their own ecosystem and make it unique. I would need a little bit more on that explanation, that creating an explanation or constructing an explanation part. As you develop your units, you will be writing your own essential questions that fit your units and whatever resources you want or whatever phenomena that you find exciting enough to teach that particular topic with. So every district or even grade or even classroom could have their own. The abiotic factors would be looked at, one with the sun when you're talking about the energy. But you could bring in other abiotic factors. When you look at this BSCS unit and we continue with all of the tools, it is going to give you an example unit. So we're going to continue this process and you're going to see where it's going to go. And at the very beginning, their engage portion, they have the students go outside and they are going to look at abiotic and biotic factors in their environment, and they're going to just list anything that they see and they're going to group them. So you're really going to hit on those two terms, biotic and abiotic, when you look at the engage of this particular example that I'm giving you. But right now, all we know is that the standard says that we need to focus on, go back to the standard, develop and use models to demonstrate the interdependence of organisms and their environment, including biotic and abiotic factors. So when I read that and I saw that that was important because it's even pulled out in the standard, I want to make sure that that's a part of my evidence of learning statement. So I said that standard 13 and 12 could be bundled, and notice that that 13 is listed first and 12 is listed second in the sample instructional model. That number at the end of the standard does not mean the order that it should be taught in. It's just a recording purpose number. It's just there to help you, okay, 6th grade team, let's go talk about standard number 12 now. It's not there to say order. So whatever order that your teams come up with when you put together your tool 1 template is going to be unique to you and what makes sense to you. And in this instance, 13 comes before 12. And 12 says to engage in argument from evidence to support a claim about the factors that cause species to change and how humans can impact those. So we want to review the standard and think about the following questions again. What's the big idea? What are those science engineering practices, those core ideas, and those cross-cutting concepts that we identified in Tool 1? And what science engineering practices from the standards are associated and connected to the core idea, always making sure that we're eventually going to hit the science engineering practice that the standard calls for. So here's our first set of evidence of learning specifications, and here's an example to the other standard. Engage in argument from evidence that is supported by evidence to support a claim about the factors that cause populations to change, and engage in argument for evidence for how increases in human population impact the Earth. Can these be rewritten to be more specific? Absolutely, but it's a good starting point. Again, going back and revising them is an important part of the process. You go back to your standard, you go back to your learning progression, you review all of your science engineering practices, and you again make sure that you've included as much as you said was important in that Tool 1 template to create an evidence of learning statement. Another thing that I have done to help teachers in this process, because these are so important for looking for the lens that you're going to look at your resources through. You want to make sure that your resources are going to get students to master the standard. These evidence of learning specifications tell you what it looks like when a student has learned it. So I've also had teachers take everything that they put on their chart, and I would have them put on one sticky, develop and use models. And I would have them put these individual words. I'd have them put patterns, and I would even have them color code them with markers. So they would write develop and use models in blue, patterns in green, and all of these words in orange, so that as they're putting their stickies together, they know that they're writing three-dimensional evidence of learning specifications, and having them rearrange their stickies into a sentence and then adding in the words that create a good sentence. And for those teachers that are having a really hard time visualizing how to create an evidence of learning statement, just them having the freedom to move stickies around has been really helpful. And then as you go through Tool 3 and Tool 4 and you're like, I still need to go back and edit those a little bit, you can come back and edit these. But having that idea of what it takes for a student to learn the standard, that backwards planning, is really helpful. So here is the template. And you list your standard with your learning progression. and what points that you've highlighted are really important about that particular standard. And then you add in your evidence of learning specifications to the bottom of the template. And that creates your tool 2 that you're going to table and hold on to until tool 5. So before we go to the reflection, any other questions about the tool 2 process? All right, so how do you think the use of tool 2 are going to help you plan for assessments that are consistent with the methods in the Arizona Science Standard? And how does the work with tools 1 and 2 help you think about the conceptual shifts that we need to make to implement our new standards? Good. Tool 2 is going to give us some focus to help us think about what our students need to learn. And it's a good backwards planning tool to identify what students need to know at the end of that particular, when you're done teaching that standard and what it looks like that they've mastered it. And yes, it really shows you that shift in how important the 3 dimensions are to our standards, that we need to be constantly thinking about those core ideas, those science and engineering practices, and those cross-cutting concepts and how they're used together to teach science. And yes, the more you practice the evidence of learning specifications, the better you get at them. Yes, we definitely want, because the standards were written in a way that we have fewer standards and we've really narrowed our focus, maybe some things aren't as important as we initially thought they were, and maybe we can let it go and allow us to go deeper into content with students. Good. I know that one was a difficult one. The evidence of learning specifications, once you get them down and you see how useful they are after you start this process, you love them, but at first you feel like you're a little bit on shaky ground. But once you start practicing with them, I know you'll get them. Yes, the point is for us to go deeper into the concept, to really get into that higher DOK level on a regular basis. And the standards were written so that we could easily integrate ELA and math into our standards. That was very purposeful. I am here for questions, so if you have any questions, feel free to ask. Just know that I can't see that it doesn't give me a little notification saying someone's typing a message or a friend's typing a message. It does not let me know that. So, yeah. Tomorrow we will be doing tool 3 and 4. And by the end of 4, we will have developed a unit. You guys are welcome. There's currently not a webinar for 5. 5, again, is a difficult concept to put in an hour webinar, just like tool 2 is. So let's see what I can work out. Tool 3 and 4 is developing a unit. There are suggested resources on it that was created by BSCS and the American Museum of Natural History. I have tried to search myself for those resources and I find them difficult to find, but I was able to recreate something similar.